Okay, let's break down some approaches. The standard VOR service volumes, there's 3, terminal, low, and high. Terminal is 25 nautical miles from 1,000 feet to 12,000 feet. Low is 40 nautical miles, 1,000 feet to 18,000 feet. High is way complicated. It's from 1,000 feet to 60,000 feet. And it starts at 40 nautical miles. Then there's a portion from 14.5 to 18. It's like 100 nautical miles, and then 130 between 18 and 45, and then back to 100 nautical miles, 45 to 60. And this is an awesome example of that. VOR, VHF, omnidirectional range, 108.0 to 117.95 megahertz, excluding frequencies at the 108.10 and 111.95 range with odd tenths. Full scale deflection 10 degrees. Distance of the course 200 feet per dot per nautical mile from the VOR station. The distance to the station, true airspeed times the minutes for bearing change divided by the degrees of the bearing change. The time to the station is seconds for the bearing change divided by the degrees of the bearing change. And the standard service volumes do not apply to published routes. The VOR limitations are cone of confusion, reverse sensing if used incorrectly, and requires line of sight to station. VOR receiver checks per 91.171 every 30 calendar days. VOT plus or minus 4 degrees. Repair station plus or minus 4 degrees. VOR ground checkpoint plus or minus 4 degrees. This is errors that you can have. VOR airborne checkpoint plus or minus 6 degrees. Dual VOR cross check plus or minus 4 degrees. Above a prominent landmark on a selected radial at least 20 miles from a VOR, flying at a reasonable low altitude, plus or minus 6 degrees. To put a proper VOR check sign-off per 91.171, use the acronym DEPS, DEPS, date, error, place, signature. Okay, our next equipment we're going to talk about is distance measuring equipment, DME. It is on the UHF station 962 to 1213 megahertz. It's normally tuned automatically with a paired VHF station, VOR LOC, VOR LOC. The airborne DME unit transmits an interrogation signal. The ground DME facility receives and replies to the interrogation. The time passed is used by the airborne unit to calculate the slant range distance from the aircraft to the station. The slant range error is negligible at 1 nautical mile from the DME station per 1,000 feet. Next, non-directional beacon. It operates at 190 to 535 kilohertz range, and it can receive and point toward commercial radio AM stations at 550 to 1650. It's low to medium frequency band, and ADF, automatic direction finder, an aircraft points toward the NDB station. The magnetic bearing equals the magnetic heading plus the relative bearing. One way I try to remember the NDB is like MLB, Major League Baseball, because you can listen to the commercial radio on the AM station, and you can listen to Major League Baseball on an AM station. So NDB, MLB. NDB service volume classes. Compass locator, 15 nautical miles. Medium high, 25 nautical miles. High, 50 nautical miles. And high, 75 nautical miles. All right, the big one. ILS, Instrument Landing System. The localizer is a frequency range 108.1 to 111.95 megahertz with odd tenths only. The width is between 3 to 6 degrees, so that the width at the threshold will be 700 feet. It's usually 5 degrees total width, 2.5 on each side, which is 4 times more sensitive than a VOR. The coverage range is 35 degrees to each side of the center line for the first 10 nautical miles, and 10 degrees up to 10 nautical miles from the antenna and up to an altitude of 4,500. And I'll try to show a picture. Okay, glide slope. Frequency range, 329.3 to 335 megahertz UHF. The glide slope is automatically tuned with localizer frequency. The width is 1.4 degrees, full deflection is 0.7 degrees in either direction. The range is typically up to 10 nautical miles. The slope is 2.5 to 3.5, and the errors is a false glide slope above normal glide slope. Marker beacons. Marker beacons provide range information over specific points along the approach, and they transmit at 75 megahertz. Marker beacons, it's only if it's on your plane. It shows, it's like a little panel with lights. There's blue, amber, and white. The outer marker, 4 to 7 miles, indicate the position at which the aircraft should intercept the glide slope at the appropriate interception altitude, plus or minus 50 feet, and you'll see the blue light will light up, like Christmas time. The middle marker, you're 3,500 feet from the runway. It indicates the approximate point where the glide slope meets the decision height, which is usually 200 feet above the touchdown zone. Amber, I kind of try to think of like street lights where it's like green, yellow, red. So the blue is the green, the yellow, amber, it's like almost there, almost there. And then inner marker, instead of red, it's white. You're between the middle marker and the runway threshold, and it indicates the point where the glide slope meets the decision height on a Cat 2 ILS, and then that approaches white. If you're on a back course marker, it will indicate the final approach fix. It'll be white, but it's not part of the ILS approach for the back course. Compass locator, low-powered NDB transmitter, at least 25 watts and 15 nautical mile range, installed together with the outer marker or the middle marker on some ILS approaches. And the approach light system helps the transition between the radio-guided flights into a visual approach, and it can help in estimating flight visibility if you know the dimensions of the specific ALS configuration. ILS categories, Category 1, the visibility 2400 or 1800 to 200 decision height, and I don't fly any of those other crazy categories, so I'm just going to stick with Category 1 because it's just a light general aviation aircraft.